Now let us say A is the midpoint of OAB, and we can say time from O to A is t by 2, that is u sine alpha minus beta g cos beta, O to A, where A is the midpoint of. Let us prove this. At A point only it has got this component, so y component becomes 0. So I can write Vy is equal to Uy plus Ay into t. So Vy is 0, Uy is u sine alpha minus beta, g is into t, and t is equal to u sine alpha minus beta divided by g cos beta. Now let us say velocity with which it strikes the point B is, here the velocity initial was u sine alpha minus beta. It's same as u sine alpha minus beta. Let us prove this. Uy is u sine alpha minus beta minus g cos beta into t is 2u sine alpha minus beta divided by g cos beta. So u sine alpha minus beta is minus, this becomes, that means here the velocity is. So a ball starts falling with 0 initial velocity on a smooth inclined plane which forms an angle alpha with the horizontal. Having fallen through a height h, the ball rebounds elastically off the inclined plane. At what distance from the impact point will the ball rebound for the second time? Now I draw a figure. The ball is falling through a height h. Let us say this velocity is v naught, and v naught obviously is 2gh when it strikes here. Now this angle is alpha, so this one will be alpha, this one will be v naught cos alpha. Now remember, when there is an elastic collision, always we should take the perpendicular component to the impact point. So this is the impact point, perpendicular is this one. So always we will have the perpendicular to the impact point, whatever the orientation of the impact point may be. If it is in this way, horizontal, then the impact point is like this. There is no purpose of taking the components here. But if the impact point is like this and the velocity is like this, you should always take the component perpendicular to the impact point. And in elastic collision, the velocity perpendicular to the impact point remains unchanged. So this is v naught cos alpha. Obviously, this will be v naught cos alpha. Now, he is saying what is the range? This one. Now, let us have time period. Time period is always 2ui, always. Ay is, this is g, this is alpha, so this is g cos alpha, this is g sin alpha. So Ay is g cos alpha, cancels out, 2v naught by g. Now range, r is equal to, and parallel component remains unchanged, so this is v naught sin alpha. So ux into t plus half ax t square. So ux is v naught sine alpha and t is 2v naught by g plus ax is up in the direction of v naught sine alpha, so there will be no negative sign, into t square is 4v naught square by g square. So this is 1 g cancels out. So this is 2v naught square sine alpha by g plus this becomes 2v naught square sine alpha by g. So this is 4 sine alpha by g into v naught square. V naught square I can write 4 sine alpha by g into v naught square I can write 2gh. So g cancels. So this r becomes 8h sine alpha. So determine the horizontal velocity u with which a stone must be projected horizontally from point P so that it may hit the inclined plane perpendicularly. The angle of inclination of inclined plane is theta h zone. Now it strikes perpendicularly to the inclined plane like this. So I will take here, this will be theta, this will 90 minus theta, this will be theta. So I take my x-axis, y-axis like this. So I think this will be theta. Now this will be u sine theta. Now it strikes, this is my x-axis, this is my y-axis. Now when it strikes perpendicularly, the x component becomes 0. So Vx is equal to ux plus ax into t. Let us have the components of g first. So this is g, this is theta, this will be g sine theta. So x is 0, ux I take that to be positive, u cos theta. Ax is opposite to u cos theta, so minus g sine theta into, let us say this time to be t. So t becomes u cos theta by g sine theta. Now my height is, this one is the vertical distance. So I can write here, this is h. So y height is h cos theta. So y is equal to uyt plus half ayt square. So this one is vertical, so I take this one as positive only. So h cos theta and uy is again same direction, sin theta, into t is u cos theta by g sin theta, and ay is again in the same direction, plus half g cos theta into, this becomes t square u square cos square theta by g square sin square theta. So this becomes sin theta cancels. So you can solve for u to find out the value of u. So this is a question. Particle A is released from point P on a smooth inclined plane at an angle alpha with the horizontal. At the same instant, another particle B is projected with initial velocity u, making an angle beta with the horizontal. Both the particles meet again on the inclined plane. Find relationship. So let us have the acceleration first. G, this is alpha, this is g cos alpha, this is g sin alpha. Now this is alpha, obviously this will be alpha. So I'll take beta as like this. So let us say for particle B, for particle B, OP is the range. OP is ux into t plus half or small t, whatever it is, ax into t square. So ux will be u cos alpha plus beta into t. Ax supports, so half g sin alpha into t square. Now this is for particle B. Let us have for particle A. For particle A, OP is equal to half, it is released from rest, half g sin alpha into t square. So I can equate this, half g sin alpha into t square is equal to u cos alpha plus beta into t plus half g sin alpha into t square. So this one and this one cancels. So u cos alpha plus beta t is 0, or either t is 0 or this one is 0. Either t is 0 or cos alpha plus beta is 0. U cannot be 0. So when cos alpha plus beta is 0, because t is equal to 0 initial time, so is equal to 0, that implies alpha plus beta is pi by 2. So conditions is alpha plus beta is pi by 2. Particle is launched such that it grazes the 4 vertices of a regular hexagon of side A as shown. Find the range of the particle. Now this is A, so this will be A cos 60. Let us say this is x. Again this is A by 2. This will be x. Now let us have the coordinates of the particle, coordinates of the points. So A point, let us say this is projected with an angle theta. So A coordinate is x comma, this is A sin 60 root 3 A by 2, and B coordinates will be x plus A by 2 comma root 3A. C coordinate will be x plus A by 2 plus A. So this is x plus 3A by 2. Again this will be root 3A. And D coordinates will be A by 2 is A, 2A, x plus 2A, root 3A by 2, y coordinate. Now A lies on the trajectory, so I can write y is equal to x tan theta to 1 minus x by r. If you remember this, let us have the range of the particle. R is range, which is x plus a by 2 plus x plus a by 2 plus a by 2 plus x. So this is 2x plus a by 2, 2a. So y is a coordinate is root 3a by 2, x is x, tan theta, keep it like this, 1 minus x is x again, divided by range is 2x plus 2a. So this becomes x tan theta 2x plus 2a minus x by 2x plus 2a. So that becomes root 3a by 2 equal to x tan theta 2x minus x plus 2a divided by 2 common x plus a. So I think this 2 and this 2 can be cancelled out. So root 3a is equal to x tan theta into x plus 2a by x plus a. Okay. Now similarly, B lies on trajectory. Let us say this is equation 1. B lies on trajectory. So for B, I will write y is equal to x tan theta, x dash tan theta into 1 minus x dash by r. So y becomes here root 3a, x dash become x plus a by 2 into tan theta 1 minus x plus a by 2 divided by 2x plus 2a. So I will compare this, or I will divide this. This becomes 1. Let us solve this. Root 3a is 2x plus a by 2 into tan theta. So this is 2x plus 2a minus x. This will become minus a by 2 by 2 common x plus 2a x plus a. So this becomes root 3a 2x plus a by 2 tan theta. So 2x minus x is x, 2a minus a by 2 plus 3a by 2 divided by 2 into x plus a. So dividing this equation 1 and 2, equation 1 divided by equation 2, you will get a quadratic equation in terms of x. So this tan theta cancels out. You will get a quadratic equation of x in terms of a, and range you can find out 2x plus 2a. So finally you will get this answer as range is root 7. So a projectile is fired with a velocity u at right angles. So I take an inclined plane which is inclined at an angle theta. The projectile is fired in this way, right angles. We need to find out the range. So to find out range, so let us have the components of g. This is theta, this is g cos theta, this is g sin theta, this is x-axis, this is y-axis. So time period will be t is equal to 2 uy by ay. Uy is u, ay will be g cos theta, and range, that is x, is equal to ux into t plus half ax into t square. U along x-axis is 0 plus half ax is g sin theta into t square, 4u square by g square cos square theta. So range is 2u square g and g cancels, 2u square tan theta into secant theta divided by g.